Hey guys, Mr. Catlin here, looking at your second page of your homework, lesson 9. And we are filling in the missing numbers that are in the equations. The first two, just straight up multiply. The second two, what do we do to get the question mark? So let's jump right in here. We have a -2 multiplied by a -4.5. So that's going to be positive, and we just got to do 4.5 doubled, which you do that, you get 9. So positive 9 for the first one. Let's do the second one here. We have a -8.7 times a -10. And a negative times a negative we know is positive. And anytime you multiply a number by 10, you're essentially just moving your decimal one place to the right. So that is positive 87. All right, moving on to the last ones here. We're thinking, what number can we multiply by -7 to get us a 14? Well, for that product to be positive, the question mark is going to have to be negative. It's going to have to be a negative number because a negative times a negative is a positive. And we got to think of a number times 7 that equals 14, and that's clearly 2. So -2. And the last one for that section, what number can we multiply by -10 and get a positive 90? Same idea. For us to get a positive outcome, the other factor has to be negative. And what number can we multiply by 10 and get 90? And that is 9. So pretty easy stuff there. Testing your rules. And let's move on to the weather station problem. All right, we got a weather station on top of a mountain, reports temperature is currently 0 degrees Celsius and has been falling at a constant rate of 3 degrees of Celsius per hour. We have to find each temperature. Explain or show our reasoning. All right, so we got all these different temperatures. Here's the key thing, though. It's falling 3 degrees per hour. So if we think of this, I'm going to do a vertical number line because that's how you see most thermometers. So here's my vertical number line, and it's following and starting at 0. So every hour we're losing 3. So we're at -3, and then we're at -6, then we're at -9, and then we're at -12, and so on and so forth, all the way. We'll stop at -18 for right now. Let's see what that problem asks us to do. So it says explain or show. I think this is enough to show. If the rate continues to fall, what will the temperature be? 2 hours, we would expect it to be at -6. 1, 2. In 5 hours, 1, 2, 3, 4, 5, we'd expect it to be at -15. A full hour is -3, so half of that would be here, and half of -3 is -1.5. Now, this is where we have to go on the other direction of the number line. What was the temperature an hour ago? So if this is 1 hour ahead, an hour back would still be skip counting by 3, but in the opposite direction. So we got 3, we got 6. We have to keep going, right? And I didn't actually draw enough to answer all of these questions. An hour ago would be 3 degrees. 3 hours ago would be 3 times 3. We'd have to do another jump and then another jump, which would leave us at 9. Now, 4.5, I'm not going to be able to squeeze it on here because I ran out of space, but we're just multiplying these numbers times 3. We've done it every time. Half times 3, 5 times 3, 2 times 3, 1 times 3, 3 times 3. These are all just coming out positive because we're going up the number line here. So all we really have to do is 4.5 times 3, and we'll get that answer. So 15, 12 and 1, 13 and a half. So 4.5 hours ago, we expected to be at 13.5 degrees Fahrenheit. All right, and number 3. Find the value for each expression. All right, so let's do it. A quarter of 12 is 3, because 12 divided by 4 is 3, and a positive times a negative is negative. So -3. A third of 39. If I break 39 into thirds, that's 39 divided by 3. You could think of it like this. Once and 3. So 13 is my answer, but negative, because a negative times a positive is negative. And then we have -4/5 times 75 hundredths. And the way that I do these problems in my head most of the time, but I'll show you what's going on. I'm going to do 75, and I'm going to split it up into 5 parts. And that happens to be 1, difference of 2, and 5, so 15. So if I split up 75 into 5 parts, that's 15, 15, 15, 5 times. But we're going to keep 4 of those. So technically we're going to have 4 of those 15s, which is 60. So 4/5 of 75 is 60, and a negative times a negative is a positive. So that one's positive 60. And then on the next one, we're doing 2/5 times negative 3/4. Both negative, so we know we're going to get a positive answer. We just have to do 2/5 times 3/4. 2 times 3 is 6. 5 times 4 is 20. Then we can reduce that to 3/10 and positive 3/10 because negative times a negative. And then lastly, let's finish off with this 8/3 times negative 42. Okay, 8/3 times 42 over 1 is the way that I think about this. Common factor of 3. 3 will go into this. 10 and 4, so that's a 14. And 8 times 14 is 80 plus 24, so that's 104. And a positive times a negative is a negative. So that knocks those out. Just make sure that when you're multiplying, you just follow your rules and then use your skills from elementary school to multiply fractions, decimals, so forth. All right, number 4. To make a specific hair dye, a stylist will use this ratio of 1 1/8 red, 3/4 tone gray, and 5/8 of brown tone. If the stylist needs to make 20 ounces of the dye, how much of each dye is needed? Well, these types of problems, the way I set these up is I set up a table. It's always really good if you're doing ratio problems to use a table. So the 3 colors that we're using here are red, gray, and brown. So I'm going to set up red, gray, and brown. And for this particular problem, I'm also going to set up a total column because we want to know how much it's going to make. So that's going to combine them all with addition. So I've got these ratios. Okay. The red is 1 1/8. The gray is 3/4. The brown is 5/8. And if we added all those together, if we did an A, these two would combine to make 1 6/8. So I'd have to do 1 6/8 plus 3/4, which is the same as 6/8. 2 of those would make 2, and then the other 4 would make 2 1/2. So I know that all of these added together make 2 1/2. But I want to make a total of that's larger than all that. I want to make a total of what? Say 20. So I want to increase this to where I'm making 20 ounces. And I think the next one is 100. So I want to increase this to where I also make 100. So with these types of problems, you're just growing by constant of proportionality. In the first one, I'm growing from 2 1/2 to 20. And if I divide 20 by 2 1/2, I get 8. So I just need to multiply all of the first numbers by 8 to find the ratios. And to go from 100 from 2 1/2, I divide those and I get 40. So I'd have to multiply them all by 40. So what I'm going to do is I'm going to multiply all of these numbers up here by 8 to get how much I would need for my 20-ounce bottle. And then I'd multiply all the numbers by 40 to find out what would be in these. And I'm not going to take up the time to do that in this video. You guys can use your calculator for that one if you want to, because this is not technically in our unit. This is an older unit when you could use calculators. So just multiply all of these by 8 to find these, and multiply all of these by 40 to find out what the 100 mixture would be. This is the 100 mixture. And you'll get those numbers, and those will be what I check. I'm not going to do all of that on the screen. You guys can multiply with a calculator. And then we just need to circle the graphs that are proportionally related. So no, because it is not a straight line. No, because it does not go through the origin. But the other two are good because they are straight lines that go through the origin. And that's it for your second page of your homework. And don't forget to get that done by Friday. See you guys.